In 1993, Intel released a very short-lived socket 4 Pentium P5 to replace the 486. I wasn't able to find a date when it was discontinued, but its replacement, the socket 5 Pentium P54C, came out the very next year, making it quite rare compared to other Intel CPUs. This IBM PC 330 P60 is one of relatively few machines that came with the P5. We have already restored it in the previous video, but unfortunately it came with a bad power supply and a bad diskette drive. Let's see if we can repair it today. We have tried it with a borrowed power supply and diskette drive from a PS1 and an Aptiva display. It ran the very first Grand Theft Auto perfectly in low color mode, but when we tried it in high color mode, we got random garbage on the screen. So today we're also going to try it out with GTA in high color mode and the slightly newer IBM G72 display. Okay, let's see if we can fix this power supply. And it's only held together with one screw and some tabs. I think it's still partially disassembled inside. I didn't clean this power supply. It came this clean already. There was, however, some soot inside, so something was running hot before it died. So this power supply is making a very nasty coil noise from this coil here. And we have already done some troubleshooting of this power supply. We have replaced these two large caps here, and we have also replaced these smaller red ones down here. And some of those small caps had a very high ESR. So initially this power supply was completely dead, but after we replaced those caps, it actually started to work. However, as soon as we turn the machine off, that coil still makes that nasty noise. And since replacing these caps here partially fixed the power supply, I went ahead and measured and checked and ordered the remaining caps on this PCB. Unfortunately, this is not going to be an easy recap, because some of these caps are extremely hard to reach. So at the very least we need to remove this PCB here. Oh, I completely forgot. Apparently I have already desoldered this PCB and didn't solder it back. Yeah, now I actually remember, it's been a while, but I had to desolder it to be able to check these caps here, just to know what to order. And of course, it didn't make any sense to solder it back on. Before I recap a board, I always check if the PCB is clearly marked. In this case, this board is so extremely tight, it's hard to see. So instead I took a picture. So if the PCB isn't clearly marked, I can just look at the picture and check the polarity. Okay, let's start with this guy here. I think the caps we have replaced so far were all Nichicons. So I didn't suspect the caps when we did the first troubleshooting. But unfortunately, Nichicons go bad too. And it has annoying bent legs. This is no Nichicon. This is actually a Nippon Chemicon KME cap. It's a 10 microfarad 50 volt cap. Went with these red Worth branded caps for this project. The polarity is clearly marked on the board here, at least for this cap here. I'll bend the legs on every cap as I install them. And as soon as they are installed, I melt the solder again and unbend them. This way it's going to be easier to replace if someone else has to repair this board in the future, or if I make a mistake. The wires to the IC connector are soldered to the board, which makes it extremely annoying to work on this power supply. So it actually makes sense to desolder these two wires. And then we'll put them back on when we're done. Otherwise this recap is going to drive me nuts. The components are so close to each other on this PCB. It's quite hard to see which pads to desolder. Next up we have this small cap here. And it's another KME cap. 10 microfarad 50 volts. And polarity is clearly marked too, but it's really hard to see. And next one is quite hard to reach. It's quite far inside the power supply. And here it is. Now, what brand is this? I had to Google this one. It's a Marcon branded cap. Apparently they were owned by Toshiba up until 1995. According to Google, these should be some decent caps. And it's a 220 micro 50 volt cap. Polarity is clearly marked on the board. But as you can imagine, this one was a bit tricky to install. Okay, next up we have this big guy here. And it has been glued down. So let's cut that glue. And this is a Nippon Chemicon 2, an SXE cap. These new caps are slightly smaller than the old caps, but the size difference isn't huge, like it is with some older caps. This is a really tight board. Without the tweezers, I wouldn't be able to get those caps off the board. It's been a while since I ordered these caps, so I don't remember if any of these caps were low ESR caps. But I did check and order accordingly. All the remaining caps seems to be Nippon Chemicons. This one's a 2200 microfarad 10 volt cap. And I seem to have ordered a 16 volt cap. It's ever so slightly thicker, so I hope it fits. Yes, it did. I guess I did a good job measuring the available space. I'm obviously skipping ahead here. Not to bore you to death. So this is actually the last cap on the main PCB. So then we have the smaller PCB here. And it actually has a bodged cap at the back. And it has been bodged onto the pads of a transistor. So that must have been an afterthought. As I removed the glue, this leg here came off. So I wonder if that was my doing, or if this was causing our issue. Polarity is obviously not marked on this bodged cap here. The leg solder to this pad here sits very closely to this bent pin here. So I'm going to desolder this pad and bend the leg the other way, just to lower the risk of getting a short. I did the same thing with this pin here, so now there is some more space in between these for our bodged cap. I'll remove the old solder and reapply some fresh solder. I soldered the cap facing in the wrong direction, and then I'm going to bend it. This way the legs are coming off the board and raised slightly. Well, this is a first. Components are so close to each other on this PCB. These two components are actually sharing the same through hole. Okay, I found something interesting here. Check out this pad here. That pad has come off the board. I don't think it's my doing, but I can't say for sure. But luckily this is an easy fix. I'll just bend the leg of the new cap. And then I'm going to cut the leg. But I left 2 millimeters that we can solder to this trace here. I scraped some of that solder mask off. And then I'm going to add a splash of flux before I solder that leg. I hope that wasn't my doing. Okay, I'll skip ahead some more. So now all the caps are replaced on this board too. And we can install it back on the main PCB. I'll start by soldering one of the pins roughly in the middle in this row of pin headers. And then I'll make sure that the board sits flush to the main PCB before I solder the remaining pins. Before we can test this power supply, we need to solder back the 2 wires for the IEC connector. Okay, and we're done. Okay, power supply is reassembled. We might as well put the lid back on before we do the tests. Okay, let's pull the lid off the IBM. This machine is partially disassembled. because I had to borrow the heatsink. And we need to put it back in before we can do any tests. Heatsinks for socket 4 are extremely difficult to find nowadays. So we had to borrow this heatsink here when we did the ESCOM Batman project. But since then I have found the original heatsink for the ESCOM machine. So now we can return this heatsink to this machine. We have done some upgrades to this machine. So we have added a CD-ROM drive and a silly amount of RAM for Windows 95. And we have also doubled the VRAM. We're not going to do a complete reassembly quite yet. I'll just put enough stuff in for this test. This machine is not as service friendly as later PCs. It's actually quite tricky to work on. Okay, I think that's enough reassembly for a test. Okay, power connected, but not turned on. So let's see if this fixed it. Fingers crossed. Okay, apparently the machine was turned on and it turned itself off. Let's turn the power switch off and turn the power on again. Well, that's odd. It keeps turning itself off. Let's push on that power switch and turn the power on again. That is very strange behavior. It turns itself on and then it immediately shuts down. Well, that kind of sucks. Well, in that case, let's do a quick test with another power supply and make sure there's nothing wrong with the board. Okay, hopefully the motherboard is enough load for that power supply. Let's turn the power on. Power supply turned on and then turned itself off. Let's push that power switch. Oh, maybe this is normal behavior. We're getting beeps. Yeah, what if that is normal behavior? This power supply has a soft power switch, so it has this extra cable that goes to the motherboard. Okay, let's turn the power on. Power supply turned on and turned itself off. Now let's push the power switch. It turns on and it stays on. So before the repair, when we turned the power off, it started to make that coil noise. Oh no, it still makes that noise. It's not as loud, but it's definitely making some coil noise. Oh, that sucks. How extremely annoying. So replacing those caps improved it, but it didn't fix it. Something else is wrong in this power supply. Wow, that sucks. Okay, I took a break here. I did some reading. Apparently this is a very common fault, even on modern power supplies. To my big surprise, the common fix is to glue the coil to the PCB. That sounds kind of sketchy, but that seems to be the fix for coil noise in power supplies. So now I'm a bit confused. Is this power supply really faulty, or is this a design flaw? So what do you guys think? Should I glue that coil down? Or should we continue troubleshooting this power supply? Because I'm not sure how to proceed now. If we continue to troubleshoot this power supply, we're going to have to look for marginal components, because the power supply is clearly working. Before we replaced the caps, the noise was quite loud. But with brand new caps, it's not that noisy anymore. From a normal distance from the PC, as if I would use it, I can't really hear the noise. I have to get quite close in to hear that noise. I guess we could measure the passives, but the rest we can't really test. So that would mean pretty much replacing random components and measuring resistors. Well, I did some thinking. This is what we'll do. I'll install this power supply and I'll start using it, just to see if anything happens. And then I'll read your comments and proceed accordingly. I'm gonna let you guys decide this one. Okay, that brings us to the diskette drive. I don't remember what the problem was with this drive, but I wrote not okay on it. Let's take a peek inside before we test it. And apparently this is an ALPS drive. from week 1 of 1995. So that matches the date of this machine, and probably the original drive. It's a bit different from most drives I have worked on, because the lid is held down with 5 tiny little screws. Okay, here comes the lid. That also freed up the cover underneath. Okay, this piece here just fell out. So is that our issue? Or was it held down with a lid? Let's try it with a diskette. Okay, it's clearly not working. No, it was probably just jammed. So the mechanics seems to be working, even without this mystery part here. Let me see if I can figure this out. Never had a drive with parts falling out before. This part here has some grease on it. So apparently it's supposed to slide on something else. Okay, I found a similar drive. Let's see if this drive will give us a clue to where the part goes. Well, it's similar, but definitely not identical. And it doesn't seem to have this mystery part here. I did, however, notice that there is a small amount of oil here. So I think this part here should sit right here, and it fits perfectly. But I can't see what it's supposed to do. What a strange part. It just sits here. So is this just a dust cover? But in that case, why the oil? I mean, this part can't move. It's just stuck on here. So the oil doesn't make any sense whatsoever. Well, let's ignore it for now. But let's check the PCB. So I'll disconnect both heads and undo these screws. Oh, this kind of sucks. This flat flex here is soldered at both ends. But it's enough to have a look underneath. And there isn't much to see anyways. So I'll just do an inspection and see if I can see anything weird. No, everything looks okay here. So let's just test this drive and see what it does. Okay, drive connected. Let's insert a diskette. Let's turn that IBM on. I heard a clicky noise, so the display turned on. Okay, it's waking up. I think it's working. Yes, it does. But unfortunately my camera doesn't sync to this refresh rate. So we're gonna have to switch to a flat panel for now. Once in Windows, I think we can sync to the G72. But for now, this is gonna have to do. Okay, so we've got a bunch of errors because the hard drive, the mouse, something else is disconnected. But we'll ignore it for now. And I'm just gonna exit BIOS. I heard a very faint ticking noise from the diskette drive. Then we've got a 1962 error. That's a first for me, so I'm gonna have to Google this one. Okay, that seems to have something to do with the boot sequence set in the BIOS. So let's reboot and jump into BIOS with F1 and go to Start Options. But unfortunately it's correctly set to first startup device diskette drive. So that doesn't look too good. Well, I can't get the diskette out. So something is definitely wrong with this drive. Let's test the IBM with a known good drive. Just to make sure the diskette and the system is okay. Okay, replace diskette and press any key. So maybe that diskette is bad. Yes, I think it is. Let's try another one. Let's try this one here. And the machine boots. So let's swap back to the original drive. While connecting the power cord, I noticed an issue with this drive. This solder joint here is actually cracked. This trace here has come off the board slightly. So I'll reflow the power connector before we do the next test. Okay, said and done. Now let's insert that known good diskette. and turn the power on again. Okay, the drive spun up and the head is moving. Yes, that fixed it. So just a cracked solder joint. Awesome. But we still have the issue with the ejects. Something gets stuck. I can't pull the diskette out. So I think it could be this arm here that gets jammed. So if we push on okay, now it actually comes out. So maybe that was all that was needed. The power connector, however, was really tough to disconnect. So I'll add some deoxit at both ends and see if it gets any better. Yeah, that totally fixed it. I did a few more tests and occasionally it got stuck again. So I'm going to add a small amount of grease underneath this part here and test it a few more times. Well, it's a bit slow. I think I found a problem. I think it's this part here, because it moves extremely slowly when I eject. So I'm going to add some grease underneath that part. Yeah, that made a huge difference. So that was definitely the part that needed some grease. I don't have enough sound cards to leave them in every project. So let's return the Sound Blaster 16 to this machine. The CT2770, like this one here, was an original option when you bought one of these machines back in the day. We are going to need some CD audio for the next tests. So let's connect this cable here and put the lid back on. Okay, let's see if my camera will sync to this display in Windows. And yes, it definitely can. In advanced properties, I can set it to 60. That's perfect for my camera. Now let's do a proper test, where the first GTA game doesn't get more period correct than this. But first, let's jump into DOS mode. If I remember correctly, GTA doesn't run too well in Windows. Okay, so my camera doesn't sync to the refresh rate in DOS. I hope it does in the game. Oh crap, I just realized I don't have CD-ROM drivers in DOS. Well, the easiest fix is just to boot the machine from a boot floppy with CD-ROM support. Well, the power supply is incredibly noisy. We need to replace that fan with a nocture fan. But that will have to be for another video. Okay, we're in. Let's start with a quick test in low color mode. Yeah, this seems to work perfectly. This is so 90s. Oh crap, I think something is wrong with my keyboard. Okay, that kind of sucks. The arrow keys stopped working on the keyboard. Okay, keyboard replaced. Apparently I have a keyboard to repair. Let's try again. Yeah, that totally works. Now let's try to run the game in high color mode. When we tried this in the previous video with the Aptiva display, we just got some garbage on the screen. It just wouldn't work. And the question is obviously if it was caused by the display or the IBM. Let's find out. Okay, the game started. I don't think we got this far in the previous attempt. So this is probably working. Oh no! It actually doesn't. Once the game started, we're just getting a black screen. Well, that kind of sucks. So now I'm not so sure anymore if this is caused by the display or the onboard graphics. I think we need to do another test. Well, in that case, let's try something much newer. This is an LG Flatron 795FT Plus from the year 2000. This display is for the VP6 project. I have it on the bench because I'm preparing for the next installment in that project. Oh, and I forgot to mention, when I use a plastic tool and push on that noisy coil, it actually goes quiet. So I definitely think gluing it would solve the problem, but it just feels so sketchy. So I'm not sure it's the proper way to do it. Okay, here goes. Fingers crossed. And obviously, being so much newer, this display is so much nicer, but it's not period correct. Okay, here goes. And no, it doesn't work. So it's not a display. This machine just doesn't have good enough graphics. Well, this motherboard has S3 Vision 864 graphics. And we have also doubled the VRAM by installing 2 more chips on the motherboard. But apparently it's not enough to play GTA in high color mode. Well, in that case, let's install the somewhat period correct Matrox Mystique. I checked the motherboard, but there are no jumpers to disable the onboard graphics. So we're gonna have to fix it in BIOS. This card came out 2 years after this IBM, so it's not a perfect match. But it's not an unlikely upgrade on a machine like this. Let's see if this works. Okay, it seems to work. We've got a config error. In devices, and actually recognize the graphics card. So I didn't have to do anything. Only thing we need to do is to save. And it's installing the drivers, but this is standard PCI graphics, so that's not quite what we want to install. I think I'm gonna skip this, because we're not going to run the game in Windows. I'll fix those Windows drivers later. Okay, let's launch GTA and run high color GTA. Okay, what's this? Cytec display detector is about to analyze all available video modes. Let's hit enter and see what happens. Okay, it recognized our card here. Matrox Super VGA MGA Mystique with 4 megs. Well, we've got this far, but we don't have any sound. That's weird. Well, we've got sound in Windows. In that case, let's go to configure sound details. This game actually has quite a few things to choose from. We even have Gravis ultrasound in here. And a separate driver for ESS cards. And here's our Sound Blaster. But we can also choose Sound Blaster Pro. Yeah, this game has support for quite a few sound cards. Device successfully detected. Press any key. Now let's run the game again. Yes, sound is back. Okay, that fixed it. Okay, fingers crossed. Let's see if this graphics card is enough to play this game. Yes, it worked. So finally, this machine is running GTA in high color mode. Oh, that radio station sucks. I think we can change the radio station, but I don't remember how. Let's grab this one. I still suck at this game. Seems to be a popular car in this town. Let's mess around with the coppers. They should piss them off. That guy wasted himself. The camera doesn't sync perfectly to this refresh rate either. I need to save up for a new camera. Busted! Well, we're not done yet, because this game also has a 3DFX mode and 2 PCI slots. So we need to do one final upgrade to this epic IBM. And now that we have seen that this game also has support for many different sound cards, I wonder if we should try some of them out. If you're watching this sometime in the future, I'll put a link on the screen to that video shortly. If you're watching this fresh, hit the bell icon below and set it to all. Meanwhile, check out the first video about this IBM. I'll put a link on the screen here. I will end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up and a comment. If you're a regular viewer, consider subscribing to this channel. Thank you for watching. I'll see you next week.